The following video was recorded before the merger of Relium, Stratalux, and G2 into one company. We are now Mission. Let's achieve yours.
Welcome, everyone. Thank you for joining us today. Really excited to get started. We're going to be talking about the AWS Well-Architected Framework, and specifically, we're going to be talking about the reliability pillar today. So first, I'll give you a quick introduction to me. I am Jonathan LaCour. I'm the CTO of Relium. I'm a technologist and programmer. I've been using the cloud since the very early days, and I'm a bourbon junkie. It's great to meet you. And just so everyone's aware, we have some handouts that are available. You can actually see them in your GoToMeeting, GoToWebinar kind of interface. Some good information there about who we are and a little bit about some of the things that we can offer you. And in addition, we have some really smart AWS experts on with us today. Lance Allen, one of our senior cloud consultants at Relium, is on the line with us, and he is going to be available to answer questions as they come in the chat and through the questions interface. So make sure to engage in that way. But let's get started. So first, I want to introduce who we are. So Relium is actually a AWS certified consulting and managed services provider. We're based in Southern California, and we help companies make the leap, the transition to AWS. And for companies that are already on AWS, we work with them to optimize and make sure they're getting the most out of the cloud. We're also a launch partner for the AWS Well-Architected Review Program, which is convenient for this webinar. We have a lot we can really leap into and talk about on that. And our staff has actually engaged directly with AWS in formal training programs so that we're qualified to deliver well-architected reviews. And we'll talk about that a little bit more later. So just to kind of get everyone on their toes here, let's first do a quick poll question to ask how your company is currently using AWS. So just so you're aware, these poll questions are completely anonymous, so your answers are not tied to you. So you can feel free to be super honest. Don't hold anything back. So I can see answers rolling in. About half of you have voted so far, so keep them coming. I'm lucky, I get to see the results as they roll in, which is kind of sneaky and exciting for me. Kind of a good mixed bag here. All right, Joshua, let's give one more minute. We got about 75% of people have voted. All right, let's close the poll out. So as you can see, it looks like a good solid, about half of you are already using AWS for production, and that's great. That's it's a really good topic to discuss, this reliability pillar for well-architected for those of you who are already on AWS. For those of you who are taking a hybrid approach or migrating or experimenting, this is really good background information to kind of help you understand a little bit about best practices. So thank you for engaging that way. Let's keep it moving here. So let's talk about our agenda for the day. We are first going to give kind of a lightweight introduction to what the Well-Architected Framework and the Well-Architected Review Program are. If you attended last month's Operational Excellence pillar, this will be a rehash, but I'll do it in about 2 minutes to keep it quick. And then we'll dive right in. And the reliability pillar, there's some really good background information that AWS wants you to have before you really get into the best practices around defining what availability actually means, how networking can impact it, and introducing the concept of recovery-oriented computing. After that, we'll go a little bit deeper into actually designing your applications to be highly available. And we'll talk about figuring out what your availability needs should actually be, how to design your application, and then we'll also talk about some operational considerations. We will have time for Q&A at the end, and as we're going, don't hold back. You can feel free to type those questions into the questions interface right in GoToWebinar. We'll hold some of those for the end, but Lance will be jumping in and answering those questions as he can as well. So let's get started. So first, let's talk about Well-Architected, the framework at a high level. So in 2015 at AWS's annual reInvent conference, the CTO of AWS, Werner Vogels, he announced the Well-Architected Framework. And it's actually a series of white papers that they started with that target 5 separate pillars or best practices around operating and building applications for the cloud. And altogether, the framework helps ensure that you're architected properly and that your procedures and processes kind of fit and match best practices. And AWS over the years has continued to evolve the well-architected framework. And as of right now, I believe it's really the most complete and thorough collection of best practices and guidance that's really available today for organizations undergoing a cloud transformation. So we believe firmly in the well-architected framework and think it's a great resource for anyone who is either already on AWS or thinking about getting to AWS. So let's talk about the benefits of well-architected. So first and foremost, the principles and best practices in the well-architected framework will help you move more quickly. And in my experience, this is perhaps the biggest demand on an operations team in a product org. Go faster. Don't break anything, but go faster. So well-architected can really help you in that. And it can also help surface risk and help you address that risk before you put your apps into production. So that's maybe the second most common demand on product and operations orgs, right? Hey, make sure things are reliable. And as a CTO, I frequently have to make big, potentially very financially meaningful decisions. And the well-architected framework can really help that by focusing the entire organization on rapid decision-making and designing our applications and workloads to be observable. And another common problems for CTOs is benchmarking our architecture, procedures, and systems, right? Making sure that we are aligned with best practices. And well-architected is awesome for that as well. So it outlines all of these best practices that AWS has really developed after engaging with thousands of customers across many different kinds of workloads. So one way to accelerate a well-architected workload is to have a certified partner like Reliam actually perform what's called a well-architected review. And we perform dozens of these. AWS also does these with their solutions architects. And at the end, you deliver a report outlining all sorts of areas of improvement across these 5 pillars of well-architected. And here you can see, kind of based upon the dozens that we've performed, some of the data around what we discover. And you can see 92% of the time, in 92% of well-architected reviews, we find critical issues in the security pillar, and 70% of the time in reliability and operations. So even if you think that you're already a well-architected workload, you're doing everything right, odds are there's something that you might be missing, some best practices you weren't aware of, or a new feature or service that you're not fully embracing yet. And a well-architected review is an awesome way to really ensure that you're driving towards those best practices. And the well-architected review program is something that AWS created in conjunction with partners like Reliam, where we can perform free well-architected reviews and then deliver remediation that is offset by AWS service credit. So this is a really cool aspect of the program. AWS really feels that if you and your applications are well-architected, that it's more likely you're going to be successful and you're going to grow on top of AWS. And that's why they're incentivizing this way. So we have a handout that's attached to the GoToWebinar that you can see this accelerated well-architected review package. Highly recommend you take a look at it. It's essentially no cost to you. Great way to get started. So let's dive into the reliability pillar now that we have kind of foundational understanding of what well-architected is. So there's a lot of background information that's actually useful when talking about reliability to help us get on the same page in terms of terminology and how we calculate and understand what availability is. So let's start off with the understanding of what availability, the notion of availability actually means, and also the meta concept of total system availability. So for the purposes of our conversation, let's define total availability as normal operation time over the total time. And I'm sure you've all heard of the concept of 3, 4, or 5 nines to describe availability, but I think it's important to kind of quantify what those actually mean over the course of a year. As you go up in those number of nines, the amount of disruption you can tolerate for your applications becomes really small. So at 5 nines, you can only have 5 minutes of total disruption over the course of an entire year. When we talk about total system availability, we have to actually take into account other services that we depend upon. If you have a downstream service that you depend upon, where a disruption to that service actually translates directly into a disruption for your service, that's actually defined as a hard dependency. And your total system availability is actually the product of your own application's kind of designed availability and the availability of any downstream hard dependencies that you have. So this is one of those best practices. Ensure that you're careful about your dependencies and how you rely upon them. We'll get into some best practices around mitigating around that in a little bit. To increase your total system availability, there's lots of different things you can do, but redundant deployment is the most common, and we'll get into details around that as well. And that's leveraging things like Amazon's AZs, availability zones, and regions. Finally, if there's one thing you can take away from this slide, it's this piece of advice. Not all applications require 5 nines of availability. In fact, not many do. The consequences for overestimating what your availability needs are can actually be pretty huge. So consider really carefully what your needs are when it comes to availability. What's your real target? And we have some great guiding questions that we'll get to as we get deeper into the best practices. So let's have a quick pop quiz. If your application is by design built for 99.99% availability, that's 4 nines of availability, and you have one downstream dependency that actually has 99.9% availability, and that's a hard dependency, what is your total theoretical system availability? So let's maybe if you have an idea, maybe type it into the chat if anybody wants to take a guess. We actually didn't end up doing a poll for this one. Does anyone have a guess? Not all at once now. All right, since no one's taken a stab, I'll go ahead and give you the answer. The total system availability theoretically would actually be the 4 nines, 99.99, times 99.9, which is the downstream availability, which actually turns out to be 99.89. So it's reduced by that second factor, right? So you really need to consider those hard dependencies, and we'll get into more details around that in a little bit, but I thought that would be a fun pop quiz for you. So like I said, overestimating your availability requirements can actually be pretty impactful on your organization. And that's because availability isn't free. In fact, it's not cheap at all. It has a big cost. And those costs are both financial and they're operational. Every 9 of additional availability that you add necessitates a higher cost for providing service, more complex operations, redundant infrastructure, and developing more highly available software adds a lot of complexity and it adds a risk. And that requires testing and a lot of investment of time. And if you have extremely high availability requirements, you may be forced to abandon downstream services that aren't up to your kind of requirements. And that means adding scope and re-implementing that functionality yourself. And finally, extra 9s decrease your agility, right? So with higher risk comes a slower pace of change, and it really impacts your team's ability to innovate. Now, none of that is to imply that you shouldn't design reliable applications. It's really all about understanding what the business requirements are and aligning your availability requirements to those so that you can really invest in the right places. And be sure you're not over-engineering. So now let's talk a little bit about networking. So this is some background information. We're not going to go super deep into all the networking best practices that exist, but we will kind of touch on some kind of broad topics. So AWS provides a massive list of considerations that impact availability in the reliability white paper. And network topology is a big one. So is the cross-region and cross-AZ networking kind of connectivity question. Resilience to failure and misconfiguration, traffic spikes, denial of service attacks, secure private connectivity, and future growth. These are all considerations. So let's touch on a few of the best practices that can help you navigate that. The first networking best practice to share is to use large, non-overlapping private address spaces. So AWS really encourages you to err on that side of too much rather than too little. As your applications grow and scale, you need to be sure that you have plenty of room to accommodate for your service infrastructure. And in order to provide for that, you should really pick these large non-overlapping private address spaces to anticipate that future growth. Just as an example, the 10.x.x.x IPv4 address space provides over 16 million addresses. And with VPC, you can actually allocate up to 65,000 IPs in an individual VPC. So that's actually a really good place to start. 65,000 IP addresses, 16 million IP addresses, that's really good. So err on the side of too much.
Hey, jumping in, guys. This is Lance here. On that note, that was a big topic in the networking world, was having to subnet and kind of slice and dice your subnet allocations from service providers, because you were given a certain number of them, of the public IP addresses. But when you're building VPCs on AWS, you're working with a private address space, and then depending on the configuration of the subnets, AWS will provide you public IPs, but you have a full private address space to play with, and you don't want to build yourself into the wall where you're creating subnets that are small, where you're saying, oh, I only have 8 servers here, so I'll make this a /29 or a /30 to just fit those systems, and then later down the road find that you want to put more systems in the subnet. You've built yourself into a wall that you now have to work around.
Right. It's a great point, Lance. Thanks for jumping in and providing that extra context. So let's talk about the second networking best practice, which is reviewing your connectivity options. I wanted to be sure to touch on this. It's a really, really deep and complex topic. We could do an entire webinar purely based around connectivity options in AWS. And that's because you've got a lot of different choices. You can use AWS Direct Connect. You can actually provide connectivity via the public internet, or you can do VPC peering. And there's also third-party VPN appliances that are available in the AWS marketplace. AWS doesn't really go deep into this kind of question in the white paper around reliability, but they do call it out, and they refer to this Amazon Virtual Private Cloud Connectivity Options white paper, which I've linked to from this slide. We'll make sure to include that in any notes that we send afterwards. And this can really help guide your networking decisions. A lot of this comes down to ensuring you're properly balancing kind of cost and performance, latency, privacy, and security. And it really does, this white paper does really outline all of the choices you can possibly make. So definitely take a look at that and evaluate it carefully. So next up, we'll talk about security and protection. And this is a big topic, obviously, for networking, because when it comes to networking, it's all about providing connectivity into your services, and then you have to make sure that you are protected against bad actors and denial of service attacks, SYN floods, things of that nature, and also being sure that you're properly configured for private communication. So when it comes to network security, thankfully, many of the existing best practices around private networks, just generally speaking, like if you would have in a data center, they apply here in AWS as well. So for example, using subnets properly to provide a barrier between your applications and the internet. The cloud isn't magic in this particular aspect, right? You still need to follow the best practices around private networks to kind of secure them. But the area where things are a bit new and different is on the protection side. And that's because AWS has built some pretty incredible services that integrate seamlessly with the rest of AWS to provide that additional layer of protection. So the big ones to be aware of are the WAF, which is the Web Application Firewall Service, and that's a very powerful and flexible platform. And there's AWS Shield and Shield Advanced, which provide even more protection, including a huge amount of capacity for absorbing and mitigating large-scale denial of service attacks. So actually at Relium, we're big users of WAF. Like I mentioned earlier, we have hundreds of customers that actually we manage their workloads for them on AWS, and we help them with best practices. And earlier this year, we were contacted by one of our customers. They were actually had a large e-commerce workload that they hadn't yet moved to AWS, and they were experiencing some downtime and disruption. And it's an SAP Hybris e-commerce website, and they were getting hammered with requests from around the globe from mostly consumer internet connections. And it looked like there was some sort of denial of service attack going on. And they couldn't really figure out where it was all coming from or why. They had put some mitigation into their firewall appliances in their data center, but the attack was large enough that it was actually pegging the compute on their firewall nodes, right? They were falling over. And at 90+% utilization, you can't kind of sustain that for long. So we came in and we actually closed off public internet accessibility to that e-commerce workload still in the data center and routed the traffic through the web application firewall. We were able to identify where the source of the traffic was coming from and mitigate it and restore service to that e-commerce workload. And we're actually now working with them to move that e-commerce workload out of their data center and into AWS to provide even more kind of scalability and protection. So there are new and interesting tools that are provided. They all integrate very seamlessly with the rest of AWS around Web Application Firewall, Shield, and Shield Advanced. So that's a good best practice to be aware of those services and to really take full advantage. So next up, I want to introduce one more topic, one more concept, which is recovery-oriented computing. Now, this didn't come from AWS. This is a general kind of concept that comes from kind of computer science and best practices around the industry. ROC is a systematic approach to improving recovery in the case of failure. And there's a lot of information out there on the topic, but there are some key characteristics that we should really, call out. And these will be woven through all of our conversation for the rest of the webinar. So some of the key characteristics are isolation and redundancy, the system-wide ability to roll back, the ability to monitor and determine health, the ability to provide diagnostics, automated recovery, modular design, and the ability to restart. Now, we actually covered some of these topics, or at least touched on them in last month's operational excellence pillar, and we'll touch on these again in many of the future pillars. So that kind of gives you an idea that the recovery-oriented computing is sort of a bedrock concept that really permeates all of the philosophy around building applications for cloud. So I'll call back to these concepts as we're going through the best practices today. So that's all of the background information. So now we can actually dive in and discuss what it means to build a high availability application. The first step to doing that is really to start understanding your requirements and your needs. And AWS actually outlines a series of questions, guiding questions for you that you can use at the outset of a project. And they really help you understand a little bit more about your needs and set the tone for your team and your design. The questions they outline are, what problems are you trying to solve with this application? What specific aspects of that application have specific levels of availability requirement? And what amount of cumulative downtime can your workload realistically accumulate during the course of a year? Finally, this one I think is the most important question, which is what is the real impact of availability, right? If your application is down, what is the financial impact on your business? What's the opportunity cost? What is the actual, underlying cost to your business? That's the critical question, right? And it drives a lot of your future decisions. Once you're armed with answers to those questions, you can start thinking about your application design. And the first step to understand the true availability needs is to understand that most applications don't have a single availability target. If you look closer and you break down your application into smaller sets of features or components, generally speaking, you'll discover that parts of your application have different availability requirements. So let's go back to that e-commerce workload we talked about. Most e-commerce workloads, the most critical aspect is actually being able to accept orders, collect money from people, and collect that payment. That's got very high availability requirements. On the other hand, order fulfillment, you can generally tolerate a little bit less availability, and reporting even less so from that. So delays of minutes or even hours for starting the fulfillment process could be totally acceptable, and auditing and reporting could be even less critical from an availability perspective. So segmenting out those different components and defining their availability requirements individually, that'll help you focus your effort into the most critical parts of the system. You also should consider the data plane and control plane. And that's a segmentation that is pretty commonly known around the industry. The concept is that the data plane is reserved and responsible for delivering service. And usually that's in real time, right? So some examples that AWS would provide for their own services that have data plane, that would be Dynamo read-write operations, connecting to RDS databases, connecting to an EC2 instance. Those are data plane, right? That's the actual work of your application happening. Control plane, on the other hand, is more reserved for configuration or provisioning. So things like launching an EC2 instance or creating an S3 bucket. These are generally speaking less critical, and you can tolerate more kind of disruption on the control plane than you can on the data plane. So that also comes in really handy when you're planning out maintenance or upgrades. I've run operations teams for years, and one big technique, major technique for doing an upgrade or rolling out new versions of your software or your service is to focus on the data plane, maintaining 100% uptime, and really being concerned about how can I, upgrade the software and tolerate a little bit of control plane disruption to get there. So that's understanding your availability needs. So with years of experience that AWS has over those thousands of customer workloads, they've come up with some key practices for designing reliable applications. And we're going to go through each of these one by one. The first one is a fault isolation zone. So this is a construct that provides isolated services that are safeguarded from failure. Okay, you can use a fault isolation zone to deploy redundant services to increase your total system availability. And AWS provides a few different types of fault isolation zones. The primary one is really availability zones. An availability zone is ideal to be a fault isolation zone because it has low latency, right? Between, you know, in a particular region, if you have multiple AZs, there's a low latency connections between them. So it's great for deploying redundant components, as opposed to a region, which is another type of fault isolation zone. Whereas if you have cross-region kind of communication, you can have higher latency. So it's still a useful construct, but maybe you know, has different uses, different applications. And then the one that kind of gets overlooked is edge locations. So this is all of the global locations around the world where AWS has some infrastructure for CloudFront and for some of its other services for edge connectivity, edge connections. And you can't really deploy entire workloads to edge locations, but with Lambda at Edge, you can actually do quite a bit of work at the edge that you couldn't do before. So there are opportunities to leverage the edge as a fault isolation zone now. So that's a kind of a newer topic to consider. So that's fault isolation zones. So what do we actually do with them? Well, like I said, you deploy redundant components, redundant services that operate in parallel to kind of safeguard you from disruption. Avoiding single points of failure is a bedrock principle for service design in AWS. So, and it's also a key consideration for recovery-oriented computing, which we introduced you to a moment ago. Redundant components, though, they go beyond fault isolation zones. So a common anti-pattern is to rely exclusively on AZs or regions for your redundancy, and forgetting to address resiliency within an AZ. So don't just deploy your services to, say, a single compute node in an AZ. Create some resiliency inside the AZ itself. Deploy multiple compute nodes, multiple storage volumes. Make sure you're resilient in the availability zone, across the availability zones, and even across regions if you can. So that's about redundant components. This is the most kind of common way to increase your total system availability. Next up is microservice architectures. So they're one of the hallmark architectural evolutions of cloud, really, and they're born out of this recovery-oriented computing characteristic of modular design. A microservice is a small, simple, single-purpose service. And the most critical aspect of a microservice is that it has a very well-defined API and a published service availability target. Together, that information represents a sort of service contract for a microservice. And it's a kind of promise to the consumer of the microservice that they can rely on. And it's also really useful for the team itself who's actually producing the microservice, because it enables them to make whatever decisions they want to make, technology, procedures, operations, whatever it happens to be, as long as they live up to that service contract. But I will say microservices are, of course, not a panacea, and they actually end up creating some complications. So we'll discuss that a little bit more detail, but I think that the critical thing to know is breaking your application down into microservices creates, by nature, a distributed system. And that's an entire kind of segment of computing that you really need to understand. We'll talk about distributed systems best practices today as well, but just be aware of that. So let's do another quick kind of poll and find out how many of you are actually already doing, you know, kind of microservice architectures in your applications. I'm very curious about this because I know there's a lot of talk about microservices, but I think, you know, their actual permeation into applications is maybe a little bit less than we might think. Interesting results so far. About 60% of you have voted so far. Let's give it another 5 or 6 seconds. Okay, let's go ahead and close it out. All right, so 56% of you are already using microservice architectures. That's great. That's actually a little bit higher than I would have expected. And that means that you're going to be able to really take advantage of what we're going to talk about next. So when you go down that path of redundantly deployed microservices, as we discussed, you're entering the world of distributed systems. Here are some best practices that you can apply to your microservice architectures to make sure that you're creating them reliably. We'll talk through each of these individually. So the first two actually are throttling and retry with fallback. So when you're creating a microservice, you really should start out with some concept of the capacity that you're targeting for the microservice. How many concurrent connections can you, do you want to be able to serve? How many requests per second, and so on. And once you know that, you have sort of a defined capacity, and that should be part of your service contract. And you can actually bake that in to the service, that self-awareness of, I can handle this much, this is my capacity. And you should build in capacity checks to the service, and you can throttle to make sure you never exceed the capacity. So if a request comes in to your microservice and you can't handle it because you're at capacity, you can actually return a response that says, hey, client, this request has been throttled, try again later. And the client itself can then implement a graceful retry mechanism, and it can back off in an exponential manner to make sure that the service has time to recover. That's kind of the second best practice that's tied in here. Don't just kind of hammer retry, because you'll actually prevent the microservice from recovering. But retry and then maybe wait 10 seconds, and then if you have to retry again, then wait 100 seconds, and so on and so forth, kind of building that fallback in. A useful thing to be aware of is that the AWS API Gateway, which is a service you can use to kind of build out web service APIs, it actually has support for throttling built right in, and that's really helpful because you can be sure that you're doing it kind of in a tested way. AWS has already done that work for you. So the next two best practices actually are very much related to throttling and retries. So the first one is about an anti-pattern, which has become pretty common, and that's related to these request queues. So I've seen it a lot in microservices actually, where rather than throttling or rejecting requests that a microservice can't handle, it'll just queue them up and kind of let a queue fill, and then work through the queue as the service has recovered. The problem with this is it's actually kind of dangerous because you're in a distributed system. You might actually just be spreading the problem out, causing cascading failures. As one queue kind of fills up, it'll drain and fill up another queue somewhere else, and you'll start seeing kind of disruption all over your distributed system. And that gets pretty complex pretty fast. AWS actually recommends that you're better off just failing fast. Return an error if you can't handle that request, or a throttling response. Don't bother queuing things up. Put the power in the hands of the consumer of the microservice and empower them to kind of make the choice about what they want to do. Also frees up your microservice to better be able to live up to its promised service contract. So that's failing fast. Also related to retries and throttling is idempotency. And this is a big word, and I'm gonna have to say it 5 or 6 more times, so forgive me if I butcher it. It actually is, it means that an operation should be repeatable without any side effects. So Wikipedia's definition maybe is a little bit better. It says a property of certain operations in mathematics and computer science that they can be applied multiple times without changing the result beyond the initial application. So in a distributed system, timeouts, throttling, and retries are very common. So it's pretty difficult to ensure that an operation is going to happen one and only one time. There are types of operation that you need to be sure that you only do once. So it's much easier to ensure that an operation happens at least once, but maybe happens or at least is requested more than once. An idempotency token is a way to kind of track these repeated operations and make sure they don't have any side effects. So the idea is that as a consumer of a microservice, if you're making a request that might be repeated multiple times, you issue a unique token, a idempotency token, along with that repeated request to a microservice. And when a microservice receives that request, it can use the token to say, hey, have I already completed this work? If you have, you can just return that response, the same response you've already returned when you completed the job, the work in the first place. And that kind of ensures that idempotency kind of pattern throughout your system. So that's a really critical best practice. The next concept is constant work. This one is really kind of difficult to grasp. It seems like a waste of time, but in many services that actually can be a big impact on performance and predictability. So the easiest way to think about it is to think of a microservice sort of like an engine, right? If you repeatedly cycle an engine up and down, it can actually reduce your performance over time. And if you have an old car and you're trying to warm it up and get it started, it can take some time to get it kind of primed and going. And similarly, some microservices may have request caches or database caches that need to get warmed up, or other aspects of the system. And attempting to maintain a constant work, you can keep a service primed or warm. And a lot of different techniques for doing this, one of which is to just create filler work or to process work that you might, otherwise process on a spot instance, right? To kind of distribute that load over time and keep it consistent. Keeps the microservice ready to respond quickly, nothing to warm up, no cold starts. This is actually pretty common if you have a microservice architecture built around AWS Lambdas, because Lambdas can have cold starts if they're not, accessed on a regular basis. So some frameworks out there for serverless development actually have a feature where they'll keep a Lambda function warm by, calling it every couple minutes. So that's the concept of constant work. So this is one of my favorites, this next one. It's called circuit breakers. And we talked about dependencies earlier, especially hard dependencies, and how disruptions downstream can impact your total system availability. A circuit breaker is a way to help mitigate that problem, especially when it's not a hard dependency. And the idea is that any dependencies that you have downstream, you can actually monitor them in a loop. And if you encounter a disruption or an availability issue with that service, you can actually toggle a circuit breaker, which is sort of a Boolean in the microservice. And then the service can make a smart decision about what to do if it needs to contact that downstream service. It knows it's not available, and so several different patterns are available here. One concept is you could just ignore it and say, look, I'll go get that data later, right? Or you could retry it later. You can even substitute in data from a response cache. A lot of times, you're relying on a downstream service where, the request, if you make a request, say you're looking at a downstream service to get, the tax rate for a particular zip code or address, that's type of information you could, potentially cache. So if a repeated request comes in, you can at least pull what you believe is still accurate data, if possible. And then the monitoring loop, when it picks up that downstream service, being restored to normal operation, it can toggle the circuit breaker back off again, and the downstream service can then be contacted again. So this is a really useful kind of concept. The last kind of best practice around distributed systems here is really about how services behave. If you have a microservice that behaves completely differently in a normal state versus in a degraded state, that's called bimodal behavior. And AWS actually recommends you avoid that entirely. They want you to architect your microservices such that they have what they call static stability. And that means you make every effort for your microservice to operate well in isolation. So limit any environmental or downstream constraints. So even if a downstream service disruption exists or something is going on in the environment, your service behaves the same. You don't see big spikes in traffic. You don't see anything kind of misbehaving. This becomes a critical debugging kind of aspect of distributed systems. When all of your microservices are kind of freaking out at the same time because of a disruption somewhere, it's really difficult to figure out the source of a problem. So this is a very important kind of best practice. So that's a little bit on distributed systems. Let's go into operations a little bit. So last month we did do a deep dive in the operational excellence pillar of Well-Architected around operational kind of procedures. But there are some additional considerations that really weren't covered last month that are related specifically to reliability that are worth talking about. So the first up is automating your deployments to eliminate impact. This is a great best practice for most organizations because for many companies, it can be scary to push change to production. It can be viewed as risky. Big part of being cloud native is kind of trying to eliminate that and make deployment like a non-event. And there's a lot of different patterns that AWS recommends you consider. The first of which is canary deployment. And that's where you deploy your changes to a small group known as the canary before rolling out to your production systems. And once you've done a canary deployment, you can kind of monitor that small group for any impact. And if everything looks good, then you can roll it out to the remainder of your system. That said, there can be difficult situations where because of architecture or design or for some other reason, you can't do a canary deployment. Another way to kind of attack this is a blue-green deployment, where you essentially deploy two complete versions of your application, a blue environment and a green environment, one with the changes and one without, and then you kind of monitor each. You can divert traffic, you can segment by user, kind of however you decide, and then decide how you want to kind of move forward. If everything is looking good, you can take down the blue environment, leave the green environment, off you go. The last pattern is a feature toggle, where you essentially hide changes and new features behind a runtime configuration option. And then you can kind of turn them on without and watch what's happening. And if something goes wrong, you can kind of toggle it off without having to do a new deployment. Now, this is in the AWS white paper. I'm personally not a big fan of feature toggles, and that's because they introduce a lot of complexity. And I actually think, for the most part, if your deployments are going to take a really, really long time, that indicates a problem with your deployments, right? And that you should probably architect around that problem and start to attack that rather than hiding and having a feature toggle. But they are useful. Like there are certainly times in which I've used them myself. Now, no matter which of these patterns you decide to employ, the most important thing is that your deployment process should be fully automated, and everything should roll through a continuous integration pipeline, testing to kind of ensure that what you're pushing to production, you've de-risked, and you can have confidence that it's going to work. So that's about automated deployment. And real quick, I was curious just to kind of get a poll from the audience about whether or not you're fully automating your deployments. I actually expect this is a little bit higher than the microservices question. I think, as we've seen things like Jenkins become really popular, CI/CD pipelines, it's really, kind of pushed that forward. But the results are surprising me a little bit with half of you voting already. Now, granted, I did say fully automated, right? And I recognize that in a lot of organizations, you may have partially automated deployments with some small manual steps. All right, Joshua, let's go ahead and close it out. So wow, it's only 37% are fully automated. Now, because of that word fully, I actually think that's a little bit more in line with what my expectations were. But it does show there's lots of opportunity going forward for everybody, so that's good. So next up, let's talk about testing. So earlier we talked about for each one of those 9s you add, you can tolerate less and less disruption, and you're adding a lot of extra work. And one of the big and most critical things that you're adding is an investment in testing. So if you have a highly available app built on microservices, there are some test modes that you should keep in mind that sometimes get overlooked. AWS calls these out because they see them all the time, and as a managed service provider, Relium has seen these in the past, and with our customer base as we're helping them build out their CI/CD pipelines and kind of automated testing. So the first one is the availability of external dependencies. It's important in your automated testing and in your kind of continuous integration systems that you do test for, how a microservice will behave in the absence of an external dependency. If a service goes down, how will your microservice perform? Failures in deployment, right? What happens if, things only get pushed out halfway, right? What happens in that particular instance? Can a system heal itself and recover if a deployment goes awry? Latency spikes on critical services. This is a very common thing that happens that people don't test. If you're relying on a service downstream, it might not become unavailable, but it certainly could, right, get really slow or start behaving poorly. Or you could have this next bullet, a partial or total loss of network connectivity. And that could be north-south, right, out of your application into the public internet or across the public internet to another service. Or it could be east-west inside your application, cross region, cross AZ, within components. What do? You should simulate that and you should test for that. And finally, the one that has bit me more often than any of these on the list, which is DNS failures. This is one of those kind of lurking, hidden things that can bite you all the time if you're not testing for it. And so make sure that you roll that into your testing. Okay, so let's ask a quick question here. Oh wait, I'm sorry. We're actually gonna go into monitoring next. So this is the next operational consideration. And I always like to say that your customer should never know of an issue before you do. And monitoring is the most critical piece of making that a reality. AWS outlines what they call the 5 phases of monitoring. So the first is generation, and that's where critical data is generated and harvested. And AWS recommends that you gather data at multiple levels and that you instrument deeply across every layer of your application. Second is aggregation, and that's where you take all of that data and you bring it together. And you're using that data to surface insights in this third phase, which is real-time analytics and alarming. And that's the backbone of your monitoring, right? Once you have the data collected and maybe put into a data lake, you can actually start building alarms based upon that. So CloudWatch, AWS provides a great service for doing this and setting CloudWatch alarms. And that really can set you up for a lot of, kind of operational monitoring, make sure you're aware of issues before your customers are. The fourth layer is storage, the fourth stage, and that could be long-term storage, it could be mid-term storage, possibly putting a lot of this data into S3 and treating as a data lake, using something like Athena to go through and search against that data to kind of surface insights. And that's that fifth stage, which is analytics. So that at a high level is monitoring. There's lots that we could go into here, but it clearly is a big critical factor for providing reliable and highly available applications. So the last operational consideration I want to talk about is operational readiness reviews and audits. AWS suggests that you have these regularly scheduled meetings to kind of review the operational requirements, best practices, any lessons you've learned over time before you push a workload to production. And these are usually in the form of like a checklist that your team can walk through. AWS actually recommends that you have these before any major change or release. And if you haven't made a change in a release, you should still force one, maybe every, once a quarter or a couple times a year. So we actually at Reliam do operational readiness reviews with our customers to make sure, hey, this workload that we've worked with you on, it's ready to go to production now. We can do that with confidence because we've gone through these lists of best practices that we've developed kind of across observing, hundreds of workloads across our customers. So that's what an operational readiness review is. This is a practice that AWS themselves do with AWS services. So I believe that is the entire kind of set of content, and we've covered a lot. So let's do a quick summary. First, we talked about the well-architected framework and what it is, and that kind of collection of best practices that AWS provides. And we talked about the well-architected program and how Reliam and other partners like us can actually help you do those well-architected reviews and get them some free remediation thanks to AWS. And then we dived into the second of the 5 pillars we're going to be covering, which is the reliability pillar. And we talked about application design, operations, and we introduced you to some background information like recovery-oriented computing. So that's the content for the day, and we are going to have some time for questions. I hope you enjoyed the content so far. I'm going to actually pop open the questions tab here. And Lance, if there's any that you've already put an answer to, feel free to kind of chime in and provide any kind of feedback you have, but I'm going through here now.
Okay, one of the questions asked by Michael Williams was talking about critical issues that we found when doing the review service, this well-architected review. And I provided the example to him. Typically, the critical issues that we see are security related, pertaining to the IAM service and how operators on AWS are misconfiguring IAM users, groups, policies, and roles, and just certain situations where there are overly permissive things happening. Maybe an application has an API key that was generated by the root user and has full control over the account. That would be something that we deem as critical. Any kind of anything that could lead to a breach or a large issue on your account, we would deem critical.
Great. Thanks, Lance, for that. I saw another good question come in also from Michael. Thanks for being active, Michael. Appreciate you kind of bringing forward all the questions. You talked about IPv6. So when we were talking about kind of choosing large non-overlapping IP ranges, absolutely V6, right? You get a much bigger namespace, right? You can have enough IP addresses for every atom of every CPU in every server that you're running on. So absolutely, V6 is certainly kind of something you can adopt. And obviously AWS supports IPv6 pretty well. I will say that a lot of software out there unfortunately doesn't. So I'm a big believer in IPv6. I run it on my home internet connection. I try to build all of my services with IPv6 native kind of capability. But there is a lot of software out there that hasn't really paid attention to IPv6. So I think it's definitely something you can do. But if you're going to have both IPv4 and IPv6 connectivity, I think it certainly does apply that you should use large, non-overlapping IPv4 ranges. So that's a good question.
I got another question. I got a good question about the web application firewall in regards to architectural best practice from Raman,
Sure.
asking about something called WAF sandwich. It's a funny term, but it is an architectural best practice for running a firewall layer on top of your application. That's actually filtering incoming requests.
Right.
And that involves basically running another auto-scaling component of firewall systems in front of your application. And it's typically sandwiched between elastic load balancers. So all your incoming web traffic is being routed through this auto-scaling system of firewalls. With the AWS WAF, the logical diagram looks a little bit different, but it's technically the same thing. What you're doing is creating WAF rules that are being bound to your load balancer, the application load balancer, which is actually invoking the kind of rule set to be applied against the incoming requests at the firewall, or I'm sorry, at the load balancing level. So it's basically filtering incoming requests still at the same layer. It's past load balancing, right past load balancing, but before the application layer. Before your application gets served a request, it's going through WAF. So it's still the same flow. It's just you're eliminating the need to run this extra compute. But you can certainly use it to complement an existing auto-scaling group of other firewall systems. If you find something cool in the marketplace, there's a lot of partners out there who are deploying things that you can leverage, and big teams like Cisco and Juniper with firewall software. Maybe not necessarily for web applications, but there's a big ecosystem to choose from.
Right. Well, great. So I think we hit most of the big questions in the list. So I definitely want to thank everyone for coming out. I really appreciate it. You will get a kind of request for some feedback that really helps us make sure we design these webinars to be really useful to you. So if there's additional content you'd like to see as part of it, or some parts you found confusing, definitely let us know. We really appreciate it. And I'd also encourage you to take a look at that well-architected review program. That is such a huge and amazing thing. Our customers love it. Every single one that we've done has resulted in some really great insights. And like I said, it's basically a free thing. You go through the process and you get 20 hours of work out of Reliance engineers essentially for free, because AWS gives you a service credit for it. So it's a very cool program. Definitely recommend you take advantage of that. And otherwise, we will see you next month for our next webinar. You can also be on the lookout for blog posts that we will be creating, which will include all of this information and maybe a little bit more in kind of a different format. So if you're a little bit more of a reader than a viewer, you can definitely absorb the information that way. So thank you so much, and we'll see you next month.